Hello and welcome to AP Psychology. My name is Mrs. Seguin. Today we'll be talking about Statistics in Psychology, Unit 1.5. In this lesson, we will talk about two lesson objectives. The first is that we're going to learn to apply basic descriptive statistical concepts, including interpreting and constructing graphs, which we'll do in class tomorrow, and calculating simple descriptive statistics. And then we're going to distinguish the purposes of descriptive versus inferential statistics. Okay, before we get into all of that, let's discuss why do we even need statistics? People like to throw out random estimates. 95% of Americans drink coffee, or 50% of Americans are below the IQ of 100, or who knows, right? Random estimates often misread reality, and then they mislead the public. So statistics help to give us more accurate estimates. A lack of understanding in statistics, because most people do not understand statistics, leads to unnecessary scares. For example, an increase of 1 in 1,000 to 2 in 1,000 is a 100% increase. If the percent increase is reported, the 100% part, but the raw data is not, 1 to 2, this can lead to unnecessary fears. Descriptive statistics is numerical data that is used to measure and describe characteristics of groups. This includes measures of central tendency and measures of variation, so those are the two groups we're going to be looking at. Graphically, these data points are often organized in a type of bar graph called a histogram. Make sure when you're looking at these graphs that you read the scale and the range. So those two things are going to determine the graph itself and the statistical interpretation. All right, those measures of central tendency, you have heard of these before if you have been in 3rd grade math class. Mean, median, and mode. These are our old friends. Your mean is your arithmetic average of a distribution. So a distribution is a collection of scores arranged from, let's say, lowest to highest, right? It is obtained by adding those scores together and then dividing that number by the number of scores. So if you have 8 test scores, you want the average, you're going to add those 8 test scores together, and then you're going to divide that answer, the sum, by 8. The mode is your most frequently occurring score in a distribution. So say we have 8 test scores, 3 of them are the same. The mode is whatever that most frequent occurring score is. Now, you can have distributions where there is no mode. So if you have a group of data points and none of them are the same, you don't have a mode. And then we have the median. The median is the middle score in the distribution. So if you line them up, lowest to highest, it's the one in the middle. This is the point where half the scores are above it, half the scores are below it. Now, ideally, your median and your mean should be very close together. If you have large gaps between your median and your mean, you have what's called large variability or high variability, which we will get to in just a minute. We're going to talk about skewing the data. So you can manipulate statistics. I think a lot of people forget this. You can skew the data even, and a high or an abnormally high or an abnormally low statistic or data point can skew the statistic. So a skewed distribution is a representation of scores that lacks symmetry around the average. So the average should ideally be the center point of a set of data points, or pretty close to center. So if you have a median, of course that is your center point. If you have a median that is super far from your mean or your average, then you have a skewed distribution. A positive skew is going to skew high, a negative skew skews low. So here's a good example. If the average test score on a test is 95, that's your average, but the majority of the students made below that score, then it is probably skewed by 1 or 2 really high test scores. A negative skew example is if that same, we're dealing with that same test score. If the average score on a test is a 70, but the majority of students made above that score, it's probably skewed by 1 or 2 really low test scores. Okay, now let's get to measures of variation. These are going to tell us how similar or different data points are. So measures of central tendency with low variability, or measures that are close together, tend to be more accurate than those with higher variability. The range and standard deviation are the two units that we're going to be looking at here. Range is the gap between the lowest and the highest score. So if you take the highest score and you subtract the lowest score, that number is the range. The standard deviation is a little more complex. It is a computed measure through a very complicated formula of how much scores vary around the mean. So you have your center point, you have your mean, right? Is the next highest score, is it 2 points away or is it 10 points away? And so the closer those scores are together, the lower the variability, and the further apart they are, or the more distance between them, the higher the variability. Okay, we're going to talk about the normal curve. Now, this is a bell-shaped curve. You'll also hear this called the bell curve. It describes the distribution of many types of data. Most scores fall near the mean or the average. As a matter of fact, about 68% of your scores will fall within one standard deviation of it. And then you'll get fewer and fewer near the extremes. So it's shaped like a bell. Okay. The calculations here are complex, so I'm just going to start with the basics of how to calculate standard deviation. You're going to start by, you take your data points and you find the mean or the average. So you add them together, and then you take that number at the bottom and you divide it by the number of data points. For each number, for each data point, you're going to subtract the mean, okay, and square the result. So let's say you have a test score of 72 and the mean or average test score is an 80. So you're going to go 72 minus 80, which equals -8. Then you're going to square that number, or, to the second power, okay? -8 to the second power, or squared, equals 64. Remember that two negatives make a positive. Then you're going to find the mean, so you'll do that for each of those numbers, and then you're going to take the mean of those numbers, or the average of those numbers. And then, when you get done with the average of those numbers, you'll take the average, and you will take the square root of that number. The number that you get, having taken the square root of the average, is the standard deviation. Okay, if you look back at this chart, Class A, the means are the same, okay? The means are both 80, so the average test score is 80. However, if you're looking at Class A, the deviation from the mean is much smaller, whereas if you're looking at Class B, it's much larger. So, the standard deviation for Class A ends up being 5, so that's not a huge standard deviation. And for Class B, that ends up being 15.8. So they have the same mean, but different standard deviations. Class A has a standard deviation with low variability. Class B has a standard deviation with high variability. Okay, now on to learning objective number 2. We're going to distinguish between the purposes of descriptive and inferential statistics. So descriptive statistics are similar to naturalistic observation as a research method. You are taking the data and you are just organizing it into a meaningful format. So whether that's into a bell curve or a histogram or a pie chart even, you are just organizing the data into a format that's easy to use. You're not doing anything with the data. You're not interpreting it. You're not going, well, this data means such and such. It doesn't matter. That's not descriptive statistics. Inferential statistics, you're going to take those raw data points, right, that's been organized into a meaningful format, and you're going to infer from that data something true about the general population. So, if you take, let's say, a random sample of the IQs of Cumberland Academy High School, and you put that on a bell curve, that is descriptive statistics. You have taken the IQs, you've taken the data points, you've put them on a graph. Cool. Descriptive statistics. Now you're going to take that data and you're going to infer things. You're going to say, well, the average IQ of the teenage population of Tyler, Texas is such and such. This infers from that data. You're taking what's true about this population and you're saying it's true about the general population. All right, the rules of inferential statistics. Representative samples are better than biased samples. That should be pretty clear. Less variable observations, so observations that are closer together, data points closer together, are more reliable than those that are more variable. So the lower the variability, the more reliable. And then more cases are better than fewer. The more things you have confirming the same conclusion, the more reliable the conclusion. I want to bring this particular quote up because it brings up a really good point. It's from page 60 of your textbook. It says, "Smart thinkers are not overly impressed by a few anecdotes or stories. Generalizations based on a few unrepresentative cases are unreliable." So I'm sure you've had those people in your life that are, well, you shouldn't get that vaccine because this one person I know had a really bad reaction to it. Okay, that one person that you know had a really bad reaction to it. Has everybody had a really bad reaction to it? No. So statistically, and as far as smart thinkers are concerned, we're not looking for, well, she knows somebody who knows somebody who knows somebody who knows somebody that had something happen to them when they did this thing. We're looking at, where's the statistics? Where is the study? Okay. Now we're going to look at statistical significance. This is a statistical statement, and I'm going to use this word a lot, of how likely it is that the result you got occurred by chance. So did you actually get the result because of how you say you got the result, or did you get the result by chance? The more times you've repeated it and the closer you keep your statistics together, the less likely it occurred by chance. So often you'll hear things like you have to do something 2 or 3 times so it establishes statistical significance. All right, we're going to stop, fill in your notes, make sure you understand descriptive statistics, including your measures of central tendency and variation, as well as the differences between the purposes of descriptive statistics and inferential statistics. All right. In this lesson, we learn to apply basic descriptive statistical concepts, including interpreting and constructing graphs, which we will do in class tomorrow, and calculating simple descriptive statistics. We also distinguish the purposes of descriptive and inferential statistics. Tomorrow in class, we are doing the statistics application activity. That night you do not have homework, yay. The day after, however, you come back for topic quiz 1.5. Guys, we have one more section left in this unit. We're almost there. All right, here's your meme for the day. All right, that is all I have for you today. I'll see you tomorrow in class. Bye.